Okay, now we have all this air in the atmosphere, and we call these air masses. So I just quickly want to go over one few slides on what these air masses are and where they're located and their different characteristics, because that's what affects the weather here in the United States. Now, basically, an air mass is just a mass of air with uniform temperature, humidity, and stability characteristics. And they develop by the characteristics of their source region, which I'll show you in a couple slides. So here's how we classify them. Moisture, either M for maritime, meaning it's wet, or C for continental, meaning it's dry. And then for temperature, A for Arctic, B for polar, T for tropical, E for equatorial, and double A for Antarctic. Mostly we're just going to be concerned about the T types today and the P's. Okay, so that's how we classify it, by the moisture and the temperature, and they are developed by the characteristics of their source regions. Now, three types that mostly influence the United States. The first one is what we call the CP, the continental polar. It's only in the northern hemisphere. It develops in the winter, and we have cold, stable conditions. We have two maritime polars, one on the east coast, one on the west. Maritime polars, meaning that they're cool and they're wet over the northern oceans, cool, moist, unstable conditions. And then two maritime tropicals, one on the east and one on the west, one on the Gulf Atlantic and the warmer parts of the Pacific in the west. Okay, so in this case, the air is going to be warm and moist. And so that's where they are. So during the winter, remember, the sun is in the southern hemisphere, so the pressure systems are kind of pulled down in latitude a little bit. So the maritime polars come down and influence the west coast here and this part of the eastern North America. Continental polar brings that cold air. Remember the jet stream and the Rossby waves. That cold air comes down over the continents because there's heat here, heat there, no heat here on the land because the land loses its heat energy much faster. And that allows this cold air to come down where it runs into the two maritime tropicals here in the Gulf Atlantic and over here in the Pacific. They're warm and humid. Where these meet, we get frontal systems, which we'll talk about in the next part of the lecture. During the summer, the sun goes back up to the northern hemisphere, so all these go up in latitude, and we become under the influence of, to some degree, the maritime tropical, warm and humid, although the moisture here is still pretty cool, so we get hot, dry summers. But over here, all this warm, moist air, that's what creates our thunderstorm systems over here. And the two polars go up in latitude. And then the CP almost disappears entirely. It's just, instead of really cold and dry, now it's just cool and dry. So those are the pressure systems, the air masses that influence North America. Okay. And then this is what gets, let me go back one slide real quick. Okay, so where these meet, where this warm meets that cold, that's what creates our frontal lifting. So go to the module, the weekly module, and watch the front video there, and it'll explain these in some detail. And you can also find the one in the study area that's also an animation. It's this animation. I'll show this to you. So there's two types, warm fronts and cold fronts. The warm front, the leading edge is a warm air mass. You're going to get all day rain and nimbostratus clouds. Okay, so the warm air is gently lifted over the cool air mass, and as it does, it cools down and we get moisture. That's your warm front. It's indicated by, usually in red, with these these semicircles right here. The cold front is the leading edge of a cold air mass, and it's usually indicated by blue triangles. Okay, so it's moving and it runs into the warm air, and it's lifted very, very abruptly. So notice this is very gentle and this is very abrupt. So we get the cumulonimbus clouds, our thunderstorms and so forth. Okay? So it's denser. The air is denser. It uplifts the warm air very rapidly, where it cools down very rapidly. Big exchange of heat energy. We get cumulonimbus clouds and generally our thunderstorms. So those are our two fronts, cold and warm. Okay, so let me stop here and then we'll get into mid-latitude cyclones on the next one.